Hello dear students. So I have come up with a problem from the book Pathfinder. There is a parallel plate capacitor which is completely filled with a dielectric. The thickness is D and the dielectric constant is epsilon r. I will take it as K only. The plates are square sized L cross L and the plates are given a charge Q and minus Q. The lower plate is glued to the table. Now the upper plate is shifted by a small distance x along one of its edges and set free. We have to find the period of oscillation of this plate. So what I have done is, once you shift the plate like I have shown in the diagram by a small distance x, the charge will redistribute itself. So effectively there will be a capacitor of plate area L into L minus x, because the whole of the charge will now redistribute itself on this area, reduced area. So capacitance will be K times epsilon naught L minus x by D, and if you differentiate with respect to x, you get the value of dc by dx as minus of K epsilon naught L by D. Now once you come to the energy analysis, energy is given by Q square by 2C. I have used this formula since charge will be conserved here, and then you get du by dx. Q square by 2 being a constant, you can take it out and differentiate 1 by c with respect to x. So you will get minus 1 by c square into dc by dx as the differentiation. Now from equation 1 we get dc by dx as minus K epsilon naught L by D, which is a negative number. So effectively we can say that du by dx is a positive quantity. Now if du by dx comes out to be a positive quantity, this is a case of stable equilibrium and there will be a restoring force acting on the upper plate. Now this restoring force we can further calculate by getting the value of du by dx modulus. And du by dx we have already calculated by equation 2. If you substitute that value, further you can see that there is a function of 1 by L minus x whole square. And if you make some binomial approximation for small value of x, then you get this value. So after substituting this value, you get restoring force, and like you can see, I have written everything here. So the restoring force finally comes out to be this function. This is of the form some constant multiplied by 1 plus some constant b into x. And since it is given that x is very small as compared to L, I can overall neglect this term 2x by L in comparison to 1. So I get a constant restoring force whose value is Q square D upon 2 times K epsilon naught L cube. Dividing it by mass, I get the acceleration of the slab. Now once it moves a distance x, the time taken can be calculated using this simple kinematics equation, x equal to half at square, since u is 0. So that time I have calculated, this is the value, and to get the time period I have multiplied it by 4. So this will be your answer. Thank you very much.